A mole is not something that plastic surgeons remove. A mole is not something that lives underground. A mole that I am talking about here in chemistry is a number of things. A mole is like a dozen. Like a dozen is 12. If you've got a dozen eggs, you know you have 12 eggs. If you have a mole of eggs, you have 6,02 times 10 to the power 23 eggs. That's a lot of eggs. A lot of eggs. If you had 1 mole of jelly beans, you would have enough jelly beans to make up the entire earth. That's a lot. I want you to just imagine this town being made just of jelly beans. The road, the trees, the buildings, everything jelly beans. Now imagine the entire earth. I mean the crust. Everything, just jelly beans. Guess what? You would have 1 mole. So a mole is a number that this guy, he actually died before they came up with the number, Avogadro. So Avogadro's number is 6,02 times 10 to the power 23. This number is always provided to you on your information sheet. And it's similar to a dozen. When I tell you have half a dozen, you have 6. So mole is a way for us to work with atoms and molecules that are so small that we actually can't count them. It would take us more than our entire lives to count to this number. So what we do instead is, if you go and look at your periodic table, and you go and you find sulfur, for example, you'll see that there is a mass number written there. We've got an atomic number for sulfur and a mass number. The mass number, this 32 over here, tells me that if I have 1 mole of sulfur, I actually can go, take the sulfur, which is a powder, a yellow powder, and I can go and measure out 32 grams of it, which is a tiny little amount. But that tiny little amount of sulfur will contain 1 mole of sulfur atoms, or 6,02 times 10 to the power 23 sulfur atoms. So the entire periodic table has been set up with mass numbers that indicate the amount of moles to you. If you go and have a look at, let's use oxygen, which is a difficult one for learners often. Oxygen, as an atom on your periodic table, has an atomic number of 8 and a mass number of 16. What does this mean again? The 8 means that it's atom number 8. It also means that this is the number of protons that we have in the nucleus. And the number 16 shows us the number of protons and neutrons that we have in the nucleus. But this number 16 also means that if I have 1 mole of oxygen atoms, it will weigh 16 grams. Now, oftentimes learners struggle with oxygen because oxygen, just like hydrogen, nitrogen, fluorine, and chlorine, tends to form a diatomic molecule. And by that I mean 2 atoms combining, and we see oxygen in its natural state normally as O2. So if I have 1 mole of O2, it basically means that I have 2 oxygen atoms combined. We can also say that I have 1 O2 molecule. So mole and molecule does not mean the same thing. Molecule is when atoms combine covalently. Then it's called a molecule. Mole is a way of measuring so that we can work with these tiny, tiny little things that we can't see and we can actually count them. So 1 mole of O2 will have a mass of 16 times 2, which is going to give you 32 grams. 1 mole of O2 therefore has a mass of 32 grams. If we go and look at another molecule, let's do H2O. H2O is a molecule. Why? Because I've got 2 hydrogen atoms and 1 oxygen atom that have combined covalently, which means that they are sharing electrons to form a molecule. This is an example of interatomic forces. A covalent bond is an interatomic force, meaning it's between atoms. Another example of an interatomic force is an ionic bond or a metallic bond. So this interatomic force, covalent bonding, leads to the formation of a molecule. Whenever you have nonmetals bonding with other nonmetals, it forms a covalent molecule. So how many grams do we have in one molecule of H2? Now, one molecule of H2 is not the same as 1 mole of H2. Why not? Molecule refers to the actual H2O that we will get, meaning H2O, 2 hydrogen atoms, 1 oxygen atom. So 1 molecule of H2O and 1 mole of H2O is not the same thing. In 1 mole of H2O, we will have 6,02 times 10 to the power 23 H2O molecules. I'm going to say that again. In 1 mole of water molecules, we have 6,02 times 10 to the power 23 water molecules. So a mole and a molecule is not the same thing. 1 molecule of H2O, therefore, is not the same as 1 mole of H2O. 1 molecule of H2O will have a very tiny little mass. We clear on that? Okay. So when it comes to moles, I'm going to show you different formulae that you can use. I'm talking about formulae that we can use so that we can move from moles to grams, moles to volume, moles to concentration.